Oh shit. Here we go again.
Alright, welcome back to Big Caleb's Math and Mayhem. Alright, we're going to be solving another problem. It's another statics problem. I think it's probably it's another 2D problem. Alright. Let's go ahead and make our free body diagram. And I've already pre-drawn this for us, so I don't waste any time. Pause the video if you need to. Okay. Let me define a few things, just point out a few things that we're going to need to take notice of. Alright, let's go with our moments first. So if you notice right here, in the X direction, we're going to be taking a moment when it rotates in the direction that I've drawn for us. If we go to the moment around Y, we'll go around, the moment will take place on the rotation I've defined right there. As well as MZ, the moment around Z, around FX, or I mean FZ, that's where the moment will take place. That's where the rotation will take place. Alright, now that we know that, let's go ahead and draw two more pictures. Because you'll probably notice we're going to be needing to take a cut, because we're trying to determine the resultant internal loadings acting on the cross section at B of the pipe. And we're going to neglect the weight of the pipe. It's not really important. We're actually not even given it. Okay, so we're going to need to take a cut right here. I'm going to label cut. Okay. After that, I've already pre-drawn a few more pictures. The rest of it we're going to have to draw out ourselves. Okay, so these aren't greatly drawn pictures, but this is the first piece from C to B. Put that right there. And then this part right here would be like B, and then A, and then D. I think you get the picture. Okay, now that we know all that, we need to take a summation of forces. Let's go ahead and start doing that. Alright. Let me go ahead and actually put this right here, just to make sure we still have it. Okay. So, in the X direction going this way, if you notice on the beam, that's where it's going. Take the forces of Fx equals 0. So, Fx will just equal 0. It's pretty simplistic. I'm going to take the summation of forces in Fy going in this direction. Alright, let's find those. So, looks like we'll have Fy plus 40 newtons. Okay, so it looks like that's actually the only one we have, equals 0, so that means Fy equals 40 newtons. Good deal. Okay, actually it equals negative 40 newtons, my bad. Okay, so it actually is a 3D problem. So we need to take the summation of forces also in the Z direction. Alright, and it's going to be going this way upward. Equals 0. Alright, let's go Fz minus, so we've got acting in the Z direction, minus 60 n equals 0. So that means F of Z equals 60 newtons. Good deal. Alright, let's go ahead and start taking our moments. Alright, let's go ahead and take a moment around X. 0, So we've got our MX going in the positive direction because of the way it's going. It's going to equal MX plus. Make sure I've got everything defined here. Let's see. Alright, plus 80 newtons per meter squared minus x minus 60 newtons. Sorry, I'm working this out with y'all guys. Alright, and that is how many meters away? That is still 0.5 meters away, equals 0. Okay, let's go ahead and solve that. Let's get our calculators out. So it's going to be 80 minus 30, basically. So that's going to mean mx is equal to negative 30 newtons per meter. Good deal. Alright, let's take another moment. In the y direction, 0 my plus e. Alright, plus 60 newtons times 1.5 meters equals 0. Alright, let's go ahead and solve that out. So I believe that's actually going to be my equals 90 newtons per meter. Good deal. We got that. And let's go ahead and take for our final answer the moment about z. And I'm actually going to define some things about these forces here in a minute that I think you should know. Alright, let's go ahead and go around mz. Alright, it's going to be 30, not 30. It's going to be 40 newtons times 1.5 meters equals 0. Let's go and get our calculators out again, though I'm probably pretty sure you should be able to solve this in your head if you've gotten to this level of mathematics. Okay, so that's going to be negative 60 newtons per meter. Alright, let me define a few things about this stuff. Let's go back to our first one. Alright, so this is the shear force in the perpendicular direction. So, and this right here is our normal force parallel, and for force Z, that is our shear force perpendicular as well. Okay, so for MY, this right here is our this is actually our torsional moment. Okay, so for your final answers, you should have taken. Your final answers are going to be fx, fy, fz, mx, my, and mz. So whatever values we found for that, that's our final. That was our final answers. Okay, good deal. On to the next video.